which we got from doing FOIL. Which, yeah, so that's a visual sort of like explanation as to why we have to FOIL and not do this. This is a mistake, all right? And no matter how much I show you and try and convince you, somebody's going to do that because it's just, well, that's the way humans are. We make mistakes, right? So now let's go back to that other problem. There it is. 5x minus 2 squared. So to do this, we are going to write out 5x minus 2 times itself again, 5x minus 2. And we're going to do our, are y'all okay with the FOIL? Do y'all like the FOIL? I'm not a fan of FOIL. I mean, I don't like little cute things. Like FOIL's cute. FOIL is like a cute way of doing it, right?
Just real quick, I have 4x
minus
3 squared on my paper.
You have 4x minus 3? Really?
It's the everything else.
Interesting. Okay. Well, y'all want me to do 4x minus 3? Yeah, we'll just do this one. Was that the homework part or no, that's the notes. Okay. Interesting. Y'all let me know if there's anything like that again that happens. I might be using the wrong version here of the packet. See, I pulled up the fall 2017 version, which is a little old, so there might be a more updated version that they didn't give me. So, all right, here we go. We're going to do FOIL. I'll explain why I don't like cute things in a second, all right? Like why FOIL is nice, but it's kind of dangerous too. This times this, right? We do our first ones, we get what? What's 5x times 5x? 25x squared. And then next, 5x times negative 2 is negative 10x. The inside one, negative 10x again. And then the last one's plus 4. And when you put all that together, you have a common, or like terms in the middle. And that is it. I think the next problem will help you understand why I don't like FOIL. All right? Let's look at number 5. Is this a polynomial times a polynomial? Yes. Now, your FOIL goes bye-bye now, because FOIL only works when you have two things multiplied times two things. We call those binomials when there's only 2 and 2. We call them binomials. So when you had a binomial, you did this cute little FOIL thing. But what do you do here? You just skip the problem? And this is why in a college algebra class I don't like to teach FOIL, because it only works in one scenario. I like to teach a different sort of approach to it that works for any polynomial times any polynomial. It doesn't matter if it's 2 and 2 or if it's 2 terms times 3 terms, or it could be 8 terms times 30 terms. It doesn't matter. It's a process instead of a cute little acronym. So to do this, I think what I'm going to do is scroll down a little bit. I want to go back to FOIL for a second, and I want to do these little lines again, these little curves that I did. If we did FOIL, aren't you starting with this one, okay? Starting with the first one, and then basically hitting both of these with that first one. Yes? That would be F and then O, right? First ones and then outer ones. Then after you did that, you went to the I and the L, which meant now you're doing this one and you're passing that one to both of those. Isn't that essentially what FOIL's doing? Okay, so instead of the FOIL, think of it as a process. You start at the first term and you distribute it over to the other parentheses through everything. Then you move to the next term and distribute that through the parentheses. That is the process. So what I'm going to do on number 5 is I'm going to start with what? Start with the x and go boom, boom, boom. After I do that, I'm going to go to the next term and go boom, 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 and I'll be done. Understand that? So there are how many multiplications I have to do here? There's 6, right? Because I had 2 guys here and 3 guys here. And 2 times 3 is 6. So if I had 3 guys here and 3 guys here, it would be 9 multiplications I'd be doing, right? All right, so let's do it. So we do the first little arc here. X times x squared is x cubed. Okay, x times 3x plus 3x squared. Y'all with me? And then what's the last one for that plus 9x? Okay, so we have basically exhausted that first one now, right? It has passed through all 3 terms. So we just move on to the next one, and we pass the negative 3 through now. So be sure you pull it with a negative. Don't do 3, it's negative 3. So negative 3 through gives me what? Negative 3x squared, and then negative 3 times positive 3x is negative 9x. And then finally, negative 3 times positive 9 is negative 27. And we have one more step, and that is to collect our like terms. Ooh, our x squareds are gone, aren't they? So we will get equals x cubed. The 9x's are gone too? How convenient. Oh. X cubed minus 27. That was nice. Okay, what about this last one, number 6?
You want to FOIL the first 2.
You want to FOIL these first?
Yeah.
Okay. Oh, by the way, I didn't tell you what the technical word is for this because I told you I didn't, I'm not a fan of FOIL. I don't care. You can love FOIL and keep using FOIL and keep telling all your friends about FOIL. I don't care about that. But if you want to know what the technical name is for what you're actually doing, it's called expanding. So we expanded these expressions, we expanded them, and that's what FOIL is, it's expanding. So we are going to FOIL this or expand this first, all right? We're going to do that before we mess with this because this is multiplication. In order of operations, multiplication comes before subtraction. So you have to FOIL this first. So if you FOIL that, I'm not going to show all the steps of FOILing. Just going to give the answer. We should get r squared minus 9r plus 18. So if you were to FOIL that, that's what you would get. And then we still have minus 3r minus 2r squared plus 7. So over here on this, I've kind of jumped a step ahead. I went ahead and distributed the negative through, and it changed the signs of everything. And now I collect like terms. And I'll just stop there. That okay? Y'all take that the rest of the way? All right. All right, let's take a look at these. These are kind of like word problems. Not really. They just give you some geometric figures. Look at this number 1. Write a polynomial. Write a polynomial that represents the perimeter of the figure. What is a perimeter of something?
The outside of it.
The outside of it. So it's like if you measured with a ruler going around the outside of an object, that would be its perimeter. I was trying to explain this to my 8-year-old daughter the other day. The difference between feet, square feet, and cubic feet. Like when you measure something, it's like, oh, it's 3 square feet. I think we were talking about the amount of water in a pool. We were talking about so many cubic feet of water. And she's like, what? Cubic what? And I was like, so I was trying to explain it to her. When you're measuring perimeter, right, you're actually taking a ruler, measuring this distance, right? And then you're taking that distance, and adding them together. That would give you your distance around. That is very different than the area of something. The area of something is like if you had to paint it, it's how much stuff is in there, right? And so perimeter is like a length. We call that a one-dimensional measurement, like 1 foot, 2 feet, 3 feet. Area is square feet. And that's because it measures what's inside. And then cubic feet is if you have a third dimension and you have like, you know, some sort of like box that contains something in it, like you could pour water into it. Why am I telling you? I don't know. But perimeter is a measurement of length, and our units are going to be just like in feet, miles, inches, millimeters, right? So when they want to know what is a polynomial that represents the perimeter of this, all it's asking you to do is take this, add this, and add this. And just write them all out, added together, and your answer will be a polynomial. All right? So I don't think I'm going to do that. I think you could just write that down, then put plus that, and then plus that. You don't need parentheses at all because you're adding them together. Now this one is a little more involved. It's not terrible, but there's a little more involved here. Yeah, I can barely get that in there. There we go. This one says, find a polynomial that represents the area. Now we're talking about, you know, the stuff inside. The area of the figure, of the shaded figure below. So they're talking about this area of this stuff in here. What's the area of that? And the answer is a polynomial. It says the dimensions of the white square are x by x. That means they don't put it on the picture, but they're telling you that the distance from here to here is x and the distance from here to here is x. They're giving that to you. So how do you want to do this?
You can solve for it first by setting the two sides equal to each other. 2x minus 5 squared minus x squared.
Hold on, I'm hearing different things. Solve for x, how do you mean solve for x?
So is that
What equal to what?
the length or the two sides that it gives you?
This? I think you might be overthinking it. Because if I set this equal to this, then here's what I get. 2x minus 5 equals 2x minus 5, right? That's what I would get. And then if you try and move your x over, minus 2x, they're gone, and then you just can get negative 5 equals negative 5, which is true, but it doesn't solve for anything, right? So look, they want us, our answer is going to be a polynomial. Like we're never actually going to know what x is. Our answer was going to be some monomials together with x's, and we don't know what x is. So anyone have a different approach as to how to find the area of this shaded region?
Open parentheses, 2x minus 5 plus parentheses squared minus x squared.
2x minus 5, okay, squared minus x squared. So is that what you were going to say also?
Oh, yeah.
Yes, something like that? So why?
Because the formula to find the area is like
Length times width?
Yeah.
Okay.
Times width. So you just square it because it's the same,
Okay.
and you subtract the area of the white square, which is
Oh, okay. Now I see what you're doing. So you actually, your approach to this was, hey, how about I find the area of the entire square first, and then subtract from that little chunk inside. That's it. So this is the area of the entire thing, right? And then this is me taking away the stuff that's inside. And so to do this now, you'd have to square this, which means you'd have to FOIL or expand, right? Figure out what that is, and then at the end of it, subtract x squared. You think you could do that? No? Sure? Your answer is going to have x's in it, right? I'm just debating whether or not I want to do it or not. Well, okay, let me just see what I'm not going to show the foiling out, but if you foiled it, you get this. That's what you would get if you FOIL that. And then you'd still have minus x squared. So I'm not showing the work from here to here, all right? I'm just doing it mentally. I want you to be able to do that on your own. And then I'm subtracting the x squared. And then all you'd have to do is do 4x squared minus minus x squared, which would give you 3x squared. So your final result would be 3x squared minus 20x plus 25. See how your answer is a polynomial expression? We don't know what x is because x was never given to us. Now, had they given us 12 here, now we could go solve for x. Because then I could set this to this, and then I could solve for x, and then once I knew that, I could come in here and, you know. All right, we're moving on. Let's move to this one. Do y'all have this one on your sheet? Okay. We're about to take a break. We're just going to finish this one up, okay? All right. That looks like a house or something, an apartment. Write the polynomial that represents the total number of square feet for the floor plan below. Total number of square feet. This is the conversation I was trying to have with my 8-year-old. Square feet means what? It's area, okay? We're talking about area. What's the total square feet of this floor plan? So it's all of these together, right? It's the area of this, the whole thing, right? Everything. So wouldn't that just be this length times this length, right? Okay, so can you tell me how long this side is? X plus 12. That's x plus 12, isn't it? And then can you tell me how long this side is? X plus 6 plus 24. Which is really x plus 30, right? So this side is really x plus 30. So the total area should be that side times this side, which would be x plus 12 times x plus 30. And then you get to play your little game of FOIL, all right? Multiply it out. Numbers are going to get kind of big, but, you know, is what it is. So you should get x squared plus 42x, and then plus 360. That's it. That's the area of the entire thing. See, if no one ever tells us what x is, there's no way we can actually give an actual answer, like 500 square feet. We can't give an actual answer because we don't know what x is. So our answer should have x in it. Any questions on this? Y'all all right? You sure? All right, it's 12:21. Let's be back at 12:31. And we will start factoring. Give me a second. Let me just turn this camera off.